All right, we'll go ahead and get started. Chris and Ted, it looks like I'm having an issue with my PowerPoint, so I'm just going to go ahead and welcome people without that PowerPoint, and then I'll hand it over to you guys. So thank you everyone for joining us today. We are here for reality capture for design architects and engineers. I am Erin Lucian. I am an industry marketing specialist here at USCAD, and I'm joined today by Chris, Torres, and Ted Moberg, who will be our presenters today. I'll be helping them out with some Q&A later on in the presentation. So if you have questions during the presentation, go ahead and use the Q&A panel in the Zoom webinars controls. This webinar is being recorded, so later this week you'll receive an email or a link via email to view the recording. You can go ahead and watch it again, share it with colleagues who aren't able to join us today. So like I said, I had a couple slides for us, but my PowerPoint isn't working, it looks like. But I just want to give a quick overview of USCAD. We are a full service AEC technology consultant. We are headquartered in Irvine, California, where I am today, and we have offices across the US. We are also, you may have seen an announcement recently that we are now part of VinZero, which is an exciting global brand. We're joining forces with A2K Technologies out of Australia, CADline out of the UK, and Caprica out of India. If you want to learn more about VinZero, you can visit vinzero.com and join our Think community and learn more about how we are committing to a sustainable future and a more sustainable built environment. And now I'm just going to go ahead and hand it over to Chris and Ted. Thanks, guys.
Awesome. Thank you, Erin. Go ahead and share my screen here. Hopefully everyone can hear me. Can y'all see my screen?
Yes.
Perfect. Perfect. Hi, everybody. Thank you for joining our webinar here. My name is Chris Torres. I'm a technology consultant with USCAD. I've been with USCAD for going on a little more year and a half now. Prior to that, I worked for some large AE firms, one in particular, Jacobs Engineering. Worked there for 10.5 years as BIM manager, then VDC director. So everything from BIM, Revit, VDC coordination, laser scanning, drone technology. And yeah, so Ted, I'll pass it over to you.
Yeah, hello everyone. Ted Moberg with USCAD. I am a technology consultant here, focusing mostly on the reality capture side of things with the Leica product line. Been with USCAD, did I say this already, for 7 years, long time. Seems like only yesterday I got brought on board, but happy to be here helping Chris out with this presentation today. Thanks.
Awesome. And since Erin wasn't able to share her slides, I have a slide here that kind of shows you what USCAD does and what we focus on. We are one of the the world's largest blue beam dealer, right, Ted?
Yeah, well, there's one that's bigger than us, and that's Bluebeam.
Okay.
Awesome. As far as resellers go, yeah, we are the world's largest platinum Bluebeam reseller.
Awesome. And as far as what we specialize in, everything at AEC, all disciplines, all business lines. We have amazing subject matter experts. We can help you out, everything from creating content in production. We partner with clients, we partner with consultants, and we just help you, with your projects and project delivery. Here's another slide, just kind of showing what we offer in-house also. So everything that we're going to talk about as far as reality capture, we do in-house for you. So let's just say you were going to do a laser scan and you didn't want to go through the hassle of buying a laser scanner or doing a third party, or sorry, renting one. We can do it for you. And as you can see, we consult, we build Revit content for you. We do all the production, visualization from 4D to 5D. You name it, we do it. So our agenda for today is we're going to focus on how reality capture can help your project. We're going to get into a little bit of technical, but more just an overview of what you can do with these types of technologies. The main thing is, of course, is to get accurate as-builts opposed to do it traditionally, like with a tape measure and a notepad and pen. And then less manual work. So, less manual trips to the job site. I know if these are A&E folks, so many a times when I've done these as-builts, I've had to go 3 or 4 times, and we're not talking about driving an hour, we're talking about flying to Orange County, and I'm in Texas, just to pull one dimension. I know it's time consuming. And then how to take all that data and start designing in 3D really quickly. Ted has some amazing examples of how you can do a scan in like within hours, you're already drawing a Revit model. It's pretty amazing. Some of the learning objectives that you'll take with you today is you'll understand the basics of reality capture, how to choose the right technology, which I think that's the most important thing, and then reality capture workflows. So on this slide, the reason I have the content on the left-hand side here, it's kind of going through everything from design to operations. So I try to cover the entire project life cycle of a project. So what I wanted to show is that anywhere along this line, this chart on the left-hand side, you can actually input reality capture and how it can benefit you, either from conceptual to design when you just want to, you know, just do a quick scan with either a handheld scanner or drone, and how to start laying out things out, or to do commissioning and start handing over all that data that you collected out in the field to the client, so they can use in their further projects. So the main question that I ask when people ask me, hey, we want to do a laser scan project, I ask what's the deliverable. A lot of people say, well, we want to do a laser, we want to do a laser scan. Well, are you doing a TI improvement? Is it a new construction? Are you just wanting to collect the data just so you can have it to share with, the client? And so that's a big question, because you kind of work yourself backwards from then. So you start from the end, what's the deliverable, and then work your way backwards. And then when you find out, let's say it's a TI improvement, what data are you trying to collect? Well, I know now that I just need to do a quick, I need a quick run through of this office area with the scanner or a 360 camera, and I can use that to start building my Revit model. Another thing to keep in mind is what's your budget. If you're going to do that same TI improvement, you don't want to go right now, buy a $120,000 scanner and just have it sit there, right? You want to choose the right technology for the project. What type of project? Of course, if you're doing an outdoor scan, you definitely don't want to use a 360 camera, and I'll show you why here in a second. There's just two different types of technologies. And then I always ask about the site conditions, just because the safety is always number one. Especially if you're doing a scan to where there's a lot of moving equipment, there's forklifts, there's people moving around, there's bulldozers. You want to make sure that you can keep yourself, safe from those conditions. So some of the basics of reality capture, in an essence, it's just capturing what's out in the real world. And that's the term the industry's used for the past like 10 years or so. And then so we'll kind of explain how to go through those construction workflows. So it all starts with something called photogrammetry in my mind. Photogrammetry is the ability to take photos and have a general overlay of another photo. So it detects where it's at within space. And then after that, you can take it to a computing engine, and it'll actually stitch all these photos together. It'll create a nice, rich 3D model for you. So the one here in the center is something that you would use like a drone with. And the one on the right-hand side is just like using a 360 camera or even a laser scanner. And then on the left-hand side here, this is kind of showing you a little concept, how the drone would fly around. It's taking pictures, and it's stitching all those things together to create that rich 3D model for you. Another way is 360 cameras. You've probably seen these before. The one on the left-hand side here is a Insta360, and basically it's just a 360 camera. You hold it up with either a tripod, or you can even mount it on your hard hat. And the concept is, if I was walking through this building here, I'd walk, take a picture with my iPhone, walk, take a picture with my iPhone, walk, take a picture with my iPhone. Once you get back into the office, you upload all those images, and then it creates this little dollhouse view effect for you. So it's great for collecting as-built. It's great for turnover, commissioning. Let's say the project's over and you just want to give the owner this nice view so that they can walk around from their office without actually having to walk through the building. Here you can see we have the Leica BLK 360, which is it's just pretty small. It's got a coffee can size scanner, super light, super portable. It takes high definition 360 images. But it also does laser scanning. And another one is a Matterport. And this is used a lot in real estate. Wouldn't necessarily recommend this on a job site. Another way of collecting data for reality capture is using drones, which is unmanned air systems. And there's two ways of doing it. One is using photos, and then one is using LiDAR that's mounted onto a drone. I'm actually a drone pilot. I've been flying for probably around 6 or 7 years now. In order to fly for a project, just to FYI, you have to go through what the FAA calls a Part 107 course. It's fairly easy to go through, and the main thing they talk about is how to read sectional charts if you're flying outside, and just some safety procedures on what you should take in consideration prior to going to the job site. But you've probably seen this drone here, the white one. It's a Phantom 4 Pro RTK, and you've seen this at Best Buy, I'm sure, or on TV somewhere. But basically, it has a high megapixel camera on it. It flies at a certain altitude. Since when it takes off, it has around 12 to 15 satellites that guide the drone. So when it takes off, let's say you're flying at an altitude of 200 feet, as it's flying and taking these images, it's actually collecting the XYZ of where it's at. So it knows where it's at within the real world of where it's flying. The cool thing about that is, so you choose your flight pattern. Let's say it's a 20-acre site. You choose your flight pattern, you hit go, and it starts flying for you, and it does its own pattern that it has built into the mobile device software. You can get some rich data from there. It's not, if there's a lot of coverage, I mean by that, a lot of trees, a lot of brush, it can't penetrate that, right? Because it's just a camera. It's just working by line of sight. So in that case, you would use something like a LiDAR mounted drone. So with the LiDAR or drone mounted LiDAR, you can actually penetrate through shrubs, through vegetation, heavy vegetation. This is excellent for if you're doing something like a wetland study. I was flying out in Florida one time. We were doing a wetland study. It was like a 30-acre site, I think. And there was no way we could get our crew in there. I mean, just a marshy land, and then you can imagine alligator snakes and all that. And so rather than putting our survey team in harm's way, we rented the drone with the LiDAR mounted on it, and we flew it, and we're able to collect that rich data. Accuracy was amazing, probably with I wouldn't say sub-mil on that because we're flying pretty high, but 1/10 of a foot, which is really good for how we were flying and how much vegetation there was. And then one more thing, here's a fairly new product if you want to research it. It's called Skydio. They just actually got a huge government deal from the military. This is what the military is going to start using. It's fully autonomous, which what I mean by that is you can tell it, hey, go inspect that tower. And it actually has, clash avoidance built in within the drone itself. So it'll actually go out there and fly on its own, collecting the data for you. And it knows how to stay away 2 to 3 feet. You can actually designate that. And you can do tower inspections, bridge inspections. It's an amazing tool. And it's like $1,000. It's super cheap. So if you have any interest in that, I would take a look at Skydio, SKYDIO. So LiDAR, if you're not familiar with LiDAR technology, it's basically, so on the left-hand side, if you see this little animation here, it's basically having the scanner here. Within the scanner, it has a rotating mirror. A laser shoots out. It's a class 1 laser. So what that means is it's the same type of laser that you would use in a copier. If you looked at it within your eye, it wouldn't affect you in any way, shape, or form. So as that glass is spinning, it shoots that laser. The laser shoots to an object, and then the scanner reads the wavelength, on the distance of the wavelength, how long it took to get to that object. And that's how you form these point clouds. And so I kind of gave a little demonstration of the same thing that you would do with the drone LiDAR as well. Here's some of the methods for terrestrial, the handheld. So terrestrial just meaning that it's going to be mounted on a tripod. So all these 3 here are mounted on a tripod. This is all handheld. These are all Leica products. Of course, there are other products out in the industry. But as you'll see, and as Ted will talk about it, the RTC 360 is one of the best scanners that you can get right now for the price and just for the quality of work that it does. So you have the BLK 360. I use this a lot at Jacobs. We actually started with 1 and we ended up with like 8. I think towards when I left. It's super easy. I had an architect. I trained an architect within 35 minutes. He, to use this. He was doing manual as-builts for CVSs in the storage rooms. And then he came up to me. He goes like, "Hey, can I use that scanner?" And I showed him in the conference room. He went out there and he went and bought one with his budget, because it saved him so much time. What took him, 6 to 8 hours, he could do with there too. And then here's the RTC 360. Ted will talk about that. Then you have your higher end ones. Here's a P40 series. This is something where it can shoot the LiDAR all the way down to like a kilometer. So this is for your higher end projects, big high rise buildings, if you're going to work on those. And then here's your handheld one. This is one of the newest ones that just came out. It's called the BLK to go. And then on the right-hand side here, you can also mount, and it doesn't just work with RTC, you can mount these scanners on these telescoping tripods. And the reason you would do this, if you're doing an interior job and you need to get above the ceilings, rather than knocking all the ceiling tiles out and then doing the scanning that way, you can knock a couple of them out. Maybe if you want it in color, you can put a light just to see the color, but it'll scan in black and white for you. So all you do is open up a ceiling tile, you telescope that scanner all the way up there, you do the scan, you bring it back down. It works the same way if you're outside and you're trying to do an interior scan of a manhole. You can actually invert the scanner. It'll actually telescope downwards as well. So rather than getting a confinement permit and stuff like that, you can actually just open up the manhole and put the scanner down there. And so it saves you a lot of work and it keeps you out of harm's way. Oh, and then Ted, I think you're going to segue into this one.
Well, yeah, I just wanted, we've already seen this slide, but I wanted to throw it in there again, just to kind of talk about, looking at the different types of hardware out there. It's like, what scanner should I buy? And it comes back to this, right? What is your deliverable? What are you trying to collect? Again, what's your budget? And what type of project? All of this, and where are you in this side menu here from design through operations? Where are you in that stage too? And then all of those questions, once they get answered, we kind of start to narrow down to the type of hardware that will best suit what it is you're trying to accomplish. So they all when it comes right down to it, no matter what you're using, whether it's a 3D camera or a P50 that can shoot a kilometer away at 1/8 inch accuracy, they all capture an image. It's just what best suits your project. So yeah, right now, I would imagine the majority of you, hopefully some of you are already employing some method of reality capture, but traditionally you'd go out to the job site, right? Drive out there, as Chris mentioned, fly there, God forbid, and pull out your measurements, your implements of destruction, your tape measure or your disto or a measuring wheel or a line level, and take all those measurements as you're visiting the site, and then take really awesome field notes, whether you're marking up blueprints or just writing down things that you find, taking photos, and then bring that back into the office and realize you forgot something. Oh crap. Now, as Chris mentioned, I've got to go fly back to that site. God forbid you have to fly back. But even if you're on the job site, I got to go back out, get that again, stop what I'm doing, stop working on what I need to work on, and go recollect that information. And this process works. People are doing this right now. People are doing this exact workflow right now, and they're doing it all day, every day, and it works. But what's the cost associated with that, I think, is the thing that gets lost sight of.
Yeah. And Ted, what I always found out when I'd forget something, which is inevitable, then I have to contact the client. They would have to meet me there at the job, the job site, take their time. I'm wasting my time. Oh, just to pull one measurement, if it's a confined space and we have to pull it. It's all sorts of things that can happen. I used to do this with steam tunnels. It's very hard to do an as-built in a steam tunnel, and it's very hard to as-built a curved wall without doing a laser scan.
What's the radius of that? You take a good guess. Well, yeah, with the laser scan, you got it. And or the worst case scenarios, right? You don't go back out to the site. You're like, I just can't. I don't have time. I don't have budget. I can't do it. I'm going to guess. And I'm sure there's a lot of nodding heads out there right now going, yeah, I don't want to admit it, but I've done that.
Absolutely.
So One of the first methods of scanning is the terrestrial or tripod-based scanner. And here we have a picture of the Leica RTC. Fits in that little black backpack. It comes with a red case, but I prefer that backpack. It isn't as light as the BLK 360. That only weighs 2.2 pounds. The RTC, I think, comes in at 12 pounds, but still very manageable. Throw it on your back, take it to a job site. That backpack actually fits in a commuter jet overhead compartment. I've had a lot of flight attendants ask me if they want me to check that. First of all, I would never check my scanning equipment. I've seen how they handle that, how they handle baggage, and I do not want my scanner subjected to that kind of punishment. But anyway, the next slide here is really easy. As Chris said, it's really easy to set up. Take it out of the box, get it connected to your iPad or Android, and you're up and running, you're scanning. You don't have to use the iPad or Android Field 360 app, but it makes that interface, and we'll get into that a little bit later here in some additional slides showing you how that workflow works. But it's really easy to set up and deploy on site and pick it up on your shoulder, and that guy actually is picking it up the correct way. You want to put it right on your shoulder and hold that leg with your arm so you make sure you don't drop it, because it is an expensive piece of equipment.
Yeah. Hey, Ted, and I was doing a data center, and we actually bought it was like a roller mount.
Yeah.
Like it's really neat. So it stays level at all times, and you just mount those legs on it, you lock them in place. And as you're doing a scan, you just roll it away. It's pretty sweet.
Yeah, it makes it much, much faster. You don't have to lift it. You're just rolling it. And we actually put, Chris, those wheels, you mentioned that elevated tripod. We've got the wheels, the casters for that elevated tripod. So we can raise it and lower it quickly with just a little portable screw gun to drive that elevating pole. And then having it on wheels, we can move it around really quickly to capture lots of data. And then when you're done, you pull the thumb drive out of that scanner. It's you're not transferring via Wi-Fi, and you bring it into your desktop app to stitch all those point clouds together. And we'll get into some of the workflows and talking about that here in a couple of other slides. But that's kind of the gist of the tripod-based scanning. But this is the Viz technology is something that sets Leica apart from any other scanner out there. I'm going to do a little plug for Leica specifically here. What's showing here is the Field 360 app on the left, and all of those little red dots is where the scanner sat for 52 seconds to capture a scan. And I picked it up and moved it into the next location, pressed the button and let it run for 52 seconds, and then move to the next one. But the Viz technology that's in there, and we've got a slide, I'll show you that here, is it's tracking where it is. So it pulls together as you're scanning. It creates this floor plan. I did not create this. This is the actual scan data, a portion of the scan data that gets transmitted to your handheld device to show you, hey, did I get it all, right? If you see a big black hole in there, you realize, oh, I didn't get that janitor's closet at the end of the hallway. Let's go back there and capture it. The two pictures on the right are one of the features of the Field 360 app called geotagging. So while the scanner is running for 52 seconds or whatever settings you have it on, you can walk around with your iPad in another room, take a photo of that electrical panel or that equipment tag, and then bring up the point cloud, a 3D view of that point cloud, and then geotag that photo and say that photo belongs right there. So that later downstream, when you share this data with everyone else on your project, they'll see a little map tag floating in the point cloud. They can click on it and up pops that high res 12 megapixel photo that you took in the field. So you're not sifting through network drive folders trying to figure out where in the heck is this photo taken, what floor is it on, what mechanical room is it? Yeah, and it's not just photos, it's videos, audio notes, a link to a website, whatever you want to link it to. But yeah, most commonly people are using video and audio for that.
Yeah, hey Ted, I can give you a perfect example of this. So when I was with Jacobs, we did a lot of combined heat and power plants, so a lot of industrial work. Yep. And so we definitely had to make sure that we had all the panels accounted for and all the circuits and all the equipment boilerplates. And so what I'd have to do, I'd take a digital camera with me and I have a set of plans. And then as I took the photo, I would write down the photo name because it shows you the name of the photo. I'd write down the photo name of exactly where I was standing and then an arrow of where I was looking at.
Yep.
And then I have to go back to the office, sort them all out into different folders, into what areas. I mean, hours and hours, maybe days of doing this.
Yeah, and then trying to share that with your team, right? You got to give them the notes and the photos. Say, here's the notes to try to decrypt where the photos are. Well, here, all you do is let them open the point cloud on a free viewer on their desk, and they've got access to everything.
Absolutely. Let me go to the next slide here.
So the next one, this is kind of showing, this is a video from, there's 5 Viz cameras on the RTC. The Viz cameras are also on the BLK to go, the BLK to fly, and the BLK arc. The Viz technology is unique to Leica only. They've got it. And what it's doing on those 5 cameras, 3 forward facing and 1 facing up, is it just got done with a scan. So it knows where all those points are within a few millimeters. And then as you pick it up and track it, it'll drop off some of the points and pick up new ones because it can triangulate where they are based on all the other data that it knows. And you can walk, here you see them walking from one side of a building to another because you've probably been out on a job site and been collecting information and someone on the site says, hey, we're coming through here with something, you've got to leave. Well, with a scanner, that's a pain in the butt because you've got to actually take notes and then move somewhere else and say, okay, my project left off on scan 37 here. And then I went to that side of the building and I picked up on scan 38 here and make notes of it. The scanner with Viz technology tracks where it is. Just hit play one more time. There you go. Tracks where it is. So as you move from point A to point B, it knows within inches, depending again how far you walk, of where your last scan was and where your next scan is. And it puts them in the correct orientation. So as you move back and fill in that data and get overlap, you have a complete point cloud when you're done. Yeah,
it's pretty neat. And hey, Ted, can you talk about a little bit about stairwells and how hideous it was before?
Thank you for that one. Yeah, I almost forgot. I was working at a project out in Pasadena, California for a company I can't tell you the name of, but they put things into outer space. I'll give you that much. Anyway, I was up in the penthouse and I was looking at the point cloud on the iPad while the scanner was running and realized that I had missed a boiler room down in the basement level. So that scan got finished. I put the scanner on my shoulder. I walked down 7 flights of that stair tower into the basement, walked into that boiler room, and the Viz technology on the iPad was tracking all the way down, and it put the scan exactly where it belonged. And then I walked back up and finished the penthouse. I just wanted to test it to see if I could break it. But stairwells are very confusing for scanners because every flight looks exactly the same. But this Viz technology just completely obliterates that. You don't need to use spherical targets or paper targets to do the registration because it's doing that pre-registration on board the device while you're scanning.
Yeah, that's awesome.
Yes.
So let me go to the next one. So
thanks, you guys, for getting the questions. I see you're coming in. We're going to handle them all at the end. We're not going to let them go. So thanks. Keep putting them in the chat. The next method is a mobile scanning. So there's several different models. This one is Andy Fontana from Leica showing us the BLK to go. So it's similar to that one that Chris showed earlier, the BLK, except it's a handheld version of it. And you got to be a little careful. It has an Android and or iPhone device, and it shows you that immediate feedback. So you can see the little green line on there in that photo on the left there. That's actually showing you from where you started the scanner up. And the little green line starts to grow as you're walking through, and then it scans that area and gives you that immediate feedback to say, yep, I've got all of this room. Maybe I want to walk a little further to the end to get a little bit more detail, but it's scanning as you walk, normal walking pace. Going up and down stairs, again, tracks itself because it has dual access LiDAR and the Viz technology to track where you're walking as you're walking through space. This one's showing going down the steps. I was at the AIA convention in Iowa last fall and took the BLK down the escalator. And people were like, what in the heck are you doing? I'm like, I'm laser scanning. So yeah, really versatile, really easy to operate. I mean, it's got one button. It turns it on. And then while it's running, if you press the button again, it'll do that same geotagging feature. So it'll take that photo and it'll place that photo floating in the point cloud right where you took it. So you don't have to figure out where that photo was taken. And then again, in the office, the workflow is much the same, taking those scans together and registering them together in a complete cloud. If you did multiple walks on multiple floors, walked around the outside, we can still bind all of that data together and put it into a single point cloud to use downstream.
Hey, Ted, what's the battery life, let's say on the handheld, this one, and the RTC 360?
Yeah, so on the BLK to go, it comes with 3 batteries, and they all last for about, I'm going to say, close to 2 hours, hour and a half to 2 hours of runtime. Now, each walk that you do with the BLK to go has to be 15 minutes or less, but you can do multiple walks. The device will store up to 6 hours of walk time. So with coming with 3 batteries, you have one in your pocket, one in the BLK, and one in the charger, and you just keep cycling them, and you can scan constantly for 6 straight hours before you have to offload the data. And then you can go another straight 6 hours. God forbid you got that much walking you to do, but that would be an awful lot of scanning.
Hey, out of curiosity, if you had to stop it in mid-walk, and then go do, someone was calling or something, and come back, will it know where you stopped, and or does it? You have to reconfigure it? It is not.
It is not. It does not have the GNS. It does not. It's not aware of where it is in the world. So if you did stop, you could stop it mid-scan without going back to the base. But the best workflow is to start from the base and end in the base. If you did have to end mid-walk for some reason, they said, get out of here, I would literally just turn around and walk away and backtrack over and end the scan and then do another walk later to match the two together.
Got it.
Yep. Yeah, this is one of my favorites. This is actual data from one of our company that they were looking at bringing in actually BLK to go data scanning. And what you can see in red is their Revit project. And what's in green is the BLK to go data. And in the next slide too, you're going to see it's a little fuzzy looking. And what that is, all that fuzz in the hallway, I had like 8 people following me around like puppies while I was doing the scan because they thought it was so cool. And that's just them getting in the way of the scan. But this architectural firm had been doing renovations on this school for 20 years. And they were very confident that their CAD file and now Revit file was an exact, digital twin of what was out there on site. And I said, I guarantee you, I bet you dinner anywhere in Kansas City that I'm going to find errors, even some major errors in your Revit model. Like, no, you're not. Yeah, we found the conference room wall was out of place by 16 inches, and just about every other wall was anywhere from 2 to 8 inches out of location. And they were doing a major renovation, and that wet wall right there would have cost them a lot of money in refabricating parts because they were going to do fabrication based on their Revit model, and all those pipe lengths would have been incorrect when they got to the site. Needless to say, I didn't have to buy them dinner. So this is a really big project we did. It was a 140-year-old brick structure that we scanned. We scanned all sides of it, inside, outside, roof, and everything in between, to bring it into Revit. And with that detailed high resolution images that we've got, plus this point cloud, we're able to convert that into an LOD, I would say 200, but it's significantly higher than that. I would say there's probably closer to 300 Revit model from that data. I've got additional slices. If you want to see more of this, we can look at the cross sections and whatnot. But ultimately, why are you doing all this? Why are we scanning? Why are we creating Revit models? It's to get to a floor plan that we can get out to the field so they can run their projects, right? And that next slide shows
hey, Ted,
produced from that. Yeah.
Sorry, real quick. I just want to bring up something. So, if you say you could do this manually with a tape measure, you could probably do some of this stuff right here, right? But when you start getting to these what you would call awnings here, and getting these I don't know, these gussets or whatever, like how do you get that molding, all that crown molding? How do you? It's very hard. I'm not saying it's impossible. You'd have to have a bucket elevator, scissor lift, and it's just a lot of measuring.
Even then, you're not going to get it right. I mean, we're capturing data at a rate of 2 million measurements every second. We are saturating the surface of that wall so that we're not only picking up where are the bricks and where's the crown molding and all that detailing, the dental work, we're picking up the width of the mortar joints between the bricks. Yeah, I mean, it's an insane amount of data. Go back one slide for just a moment. When the point cloud's overlaid on top, you'll notice that you see blue in some areas and not blue in others. That's because the building is not plumb. So we modeled it in Revit perfectly square and plumb, but you can see where there's blue and then there's no blue. That's because there's movement in that brick as it's going up that tower, and that wall is not perfectly plumb. It's leaning backwards on one side and then coming back out on the top again. Those are things that you are unaware of without using laser scanner, that now you can start to see there's defects in this building. They're going to cause me problems during construction that you'd otherwise be not blissfully unaware. You find out about it eventually, but at the end of the project, when there's no money left and you've got to overcome some expensive obstacle that you didn't find, because you used a tape measure or some other measuring.
Yeah, and the reason why you want to make it plumb is because whenever you start doing your drawings, you want them all orthogonal, correct? And
yeah,
you can always
get that. Yeah, to those last two slides. Ultimately, what we're trying to produce is some Revit drawings, and Revit likes nice square corners so that it can throw in those dimensions. So now we've got beautiful, 1/8 inch or less digital twin accurate drawings of that 140-year-old building that did not exist. Not even originally did they have this level of quality of drawings to produce.
That's how long did it take for this? Just out of curiosity, do you know?
I think the scanning on site for that was, 2 days on site. They had 2 RTCs, so it went pretty quick.
Wow.
They probably overscanned it, to be honest with you, but it was a demo project, so they really did a really good job. The modeling, I don't know how long the modeling took. I should get some numbers on that. But.
Got it.
Hey guys, I just want to interject for a second and say we have about 6 minutes left in our scheduled time. So we can wrap up the presentation and we can maybe answer some questions if possible.
Yeah, so we have our last slide coming up. So it's perfect.
Great interjection. Yeah, so I guess my question back to everybody on the call is, what would you do if you could take every single person on your project, from your front desk secretary to every single person, and put the project data in their hands? So it's like being on site without being on site. I can send one person out to the site now and collect information, and they're not taking any measurements. The measurements are already there. I can click on anything that I can see to anything else I can see and get pinpoint accurate measurements. And I can put that in the hands of everyone, the estimators, the people who are doing the drawing, not just the people using the CAD tools. What kind of value would that bring to your projects? And how many issues do you think related to dimensional inaccuracies would save those pitfalls you run into during construction?
Perfect.
With that, we've got a lot of questions in here. Aaron, can you start throwing those at us? I can see the number, but.
Yeah, I can. We have a couple questions here that I think I'll start with because they were referencing that example you guys were just showing. For example, I think we've got one question here: what equipment was used? I think you just answered that with a couple of RTCs that they had on site.
Yep.
But is the data from the scanners capable of being converted directly into Revit? If so, once imported, are all objects, or presumably all objects are generic and not associated with systems like mechanical or plumbing?
Yeah.
And in that case, does everything have to be manually associated with a specific system?
So that's a lot to chew off there. I'd love to take whoever that is and take an offline meeting about that. But yes, there is. So you can take this point cloud data and run it through another product called Point Fuse, and it will segment that data and turn it into a mesh, but a segmented mesh that has IFC classifications to it. And then we can spit that IFC classified file out into Revit, and it does come in as generic Revit walls, windows, doors. They're working on pipe and duct. It's not there yet, but that's soon to come out. But Chris mentioned this before, and I forgot to say it. Really excellent workflow. BLK to go, walk your site. Maybe you're proposing the site. Walk your site with the BLK to go, run it through Point Fuse, and you'll have an LOD 200 Revit model to review with the client that afternoon, right before, right after lunch. And I can show you how you can do that without doing any modeling in Revit at all.
All right, so let's see. We've got how much data is in the scan, and are there specific hardware requirements for the computer you're going to be using? That's
an excellent question. Point clouds are gigantic. They're huge. I mean, we're talking. They're just huge. It depends on the project, depends on the resolution, but suffice it to say that the data bundles itself are huge. The raw data is huge. The project in the registration project is huge. And the file that you export, an RCP or an RCS or an LGS file, is also big. So the raw data, the project data, and the exports are all big. You need hard disk space. I can't stress that enough. If you've got a pretty decent Revit computer, probably going to be just fine to do the registration software, but you probably have wholly inaccurate amount of hard disk space. I have two 2 terabyte solid state drives in my computer. The other machine that I do larger projects on has 2 4-terabyte solid state drives, and it's also multi-core does help as well. So getting into the hardware, the more cores your processor has, the faster it'll process that data.
Yeah, and also to add to that, it also depends on what you're scanning and how, if it's a big scan, what you don't want to do is scan it all at once. You want to break it out into chunks, into areas, into floors.
Yeah.
Right, Ted?
Yeah, you don't want to scan the entire, city of Kansas City and put it all in one point cloud. You want to chop it up into logical chunks so it makes it easier to digest, because you don't need to bring the whole thing into Revit or Civil 3D or AutoCAD. You just need this floor of this building. So chop it up and manage the chunks.
Yeah, and if you don't want to bring it directly into Revit, let's say it can't handle it, you can always bring it into Navisworks, which that actually handles point clouds pretty well, and you can use that as a reference as well.
Yeah. Oh, and back to that guy who had asked this, and whatever person was who asked about the modeling, that one of the other exports out of PointFuse, it's a brand new feature, and if you want to look at it, I can set something up after this. They have a file for exporting. I mean, it's infinitesimally small, a 20, 30 gig point cloud down to 100K, and it's a file I can bring into Revit, and it represents the point cloud that I can now model off of. It's really cool new feature, and it's free. So anyway, had to throw that in.
What about accuracy of data? I think particularly drone data. Yeah,
so on the drone data, that's a really good question. So on the drone data, it all goes back to what are you trying to collect? And there's a couple of variables that are in there. And I'll give 2 examples. One, if I'm trying to get the exterior of a structure, well, then I would use something like that Phantom 4, that white drone that I was showing you. And the accuracy level all depends on weather conditions, of course. If there's really gusty, when it goes to stitch those photos, it might not be so accurate. So you want to pick like I wouldn't say cloudy day, but semi-cloudy day, low wind, and just a high-res camera on that drone, and you can get within 1/8 of an inch from a structure. And if you want to do like if you want to get down to sub-mil, then I would definitely move towards more of a drone LiDAR workflow, and that'll go down to sub-mil.
What about I want to go back to the viz that we talked about with Leica, and someone wanted to clarify that's something that's specific to Leica. Is it part of the hardware? Is it part of the software? Could you clarify that?
Yeah, the viz is stands for Visual Inertial System. If I got that correctly, that's the acronym. And it's the software, well, the firmware built into the RTC itself. So it's nothing to do with the desktop app. It's all done on board. So you don't even need to use that Field 360 app. If you scan, pick it up, move it to a new location, scan, pick it up, move it to a new location, and scan, that software on board the scanner, the viz software, interprets all those points that I showed you in that video, those red, blue, and green points, to triangulate its location from the first scan to this next scan to the next scan. But it does it all on board. It's software.
I think one final question here is the now what? Can we help provide an ROI to sell this to management, and how can we help people get started, whether it's training or what?
Yeah, that comes up a lot, and we actually have developed an ROI calculator. It's just in a little Excel spreadsheet, and we can share with you the results of that. So essentially what we do is we ask you the questions. How many projects do you do a year? Approximately how big are they? How many people do you typically send out on site? For how long? What's their billable rate? And we do the math, right? And you just figure out, and it's been an epiphany for many companies. Number one, they don't actually sit down and look at how much time they spend capturing existing conditions, as Chris said, going back over and over and over again, because they forgot. I had a very embarrassing situation once where a project manager was there with the lead architect, and the architect was telling me about all of the time spent, and then the project manager's like, we spend that much of our budget capturing existing conditions? And I said, yeah, and you're getting junk for information as well. But so that we plug your numbers into that, and it comes out at the end, and it shows you what your costs are versus what it would cost to run it with any of the various scanners. And you can kind of just see the numbers right there. How long will it take you to pay for it? In some cases, it's a single project.
Well, thank you both. I think, there were obviously some questions that, like, I think Ted, one of the questions, or one of your answers was like, that's a lot. It can be kind of specific to your specific company. So if anybody has any follow-up questions, they want to talk to Ted or Chris, their emails were just on that last slide. You can also reach out to info@uscad.com and we'll connect you with the right person. Or if you know your USCAD account manager, feel free to reach out directly to them too. But I just want to say thank you, Ted. Thank you, Chris. Thank you everyone who joined us today. Like I said at the very beginning, we did record this presentation. So by the end of this week, there will be an email that goes out with a link to view this recording if you want to share that with any of your colleagues. And yeah, have a great day, everyone.
All right. Thank you. Thanks, everybody.
Thank you.